Okay, example 5 looks like a problem that doesn't belong in this section, but let's take a closer look at what's going on here. It says how many solutions are there to the equation x1 plus x2 plus x3 plus x4 equal to 10 if x1, 2, 3, 4 are non-negative integers. So like for example, I can, let's say, make x1 be 1, I can make x3 be 5, and let's say x2 be 2, and what should I pick for x4 so that when I add all the numbers together I get 10. So that's 7, 8, maybe 2. So that's one possible choice. Or I could maybe make 0 for x4 and modify one of these guys and maybe make it a 4, for example. 1, 4, 5, and 0 will add up to 10. Here's another possible solution. I can make 5, 5, 0, and 0 again. Okay. So how many possible solutions like this one that I described are there in this particular problem? Okay. So what I'm going to do is, again, turn the problem into some sort of a diagram and kind of look at what's happening and figure out if I can count it correctly. So I'm going to start off with the little table that has x1, x2, x3, x4. And what I'm going to do is I'm going to put little x's in each one of those columns. And every x is going to count as one unit. So like for example, if I put x1 with the little x down here, that means I'm assigning the value 1 for x1. If I put two little x's in x3, that means I want x3 to have the value 2. So far 1 plus 2 does not add up to 10. So I need some more x's. So maybe I should add a few more here. So now x1 is 3, x3 is 2, and maybe I could make the x2 be 4 by putting 4 little x's in there. Then maybe x4 be 1 again. So 1 plus 2 is 3, plus 4 is 7, plus 3 is now 10. So at the end of the day, what did I actually do? So I started off with 4 groups. These are the x1, x2, x3, x4, and I had basically 10 choices to make. I had to pick 10 darts and put them into my dartboard, basically. Okay, so there are how many solutions? There are basically 4 plus 10 minus 1, choose 10 possible solutions. Okay, let's see. This is going to be 13, choose 10, which is 286 possible solutions. Okay, so these are solutions where the numbers can be 0 or they can be positive. Okay, so is that making sense or not? So this is equivalent to saying the following. It's equivalent to saying I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13, and I'm gonna put some slashes somewhere and some x's somewhere. So if I put my x's, let's say, in the first 3 spots, then I put, x's right here, then I put 2 of them right there, then I put 1 of them at the end, then there's going to be some slashes in the middle where I left the blanks. So basically what I just did is I had to pick where to put all the x's, and I start off with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I had to figure out where to put 10 x's in 13 different positions. And that's kind of the equivalent to that formula. So when I do it this way, it's kind of doing it from the perspective of section 9.5 that we did previously. Another way to think of it is to figure out where the 3 dividers are going to be placed. And so you have 13 choices. Where do you put the 3 dividers? And you can try it out. You can put this in your calculator and you'll see 286, just like you would see over here, 286. Again, this is symmetry, and we're going to take advantage of it when we're talking about the Pascal triangle and the binomial theorem. So now what's going on in part B? Well, they're saying they want the solutions where x1, x2, x3, x4 add up to 10, but this time they want each of the x's to have at least one little dart. So basically, I have to make x1 be 1 at least, x2 has to be 1 at least, x3 has to be 1 at least, and so on. Okay, so basically, x1 minimum is 1, and so on. How many darts am I left with? How many darts can I actually control? Well, I want the total to be 10, and I already used 4 out of 10. So there's 6 more darts to go around. So I could put maybe all of them here. Maybe I could put some of them right there, and then maybe 1 at the end. Okay, so that's pretty much what is happening. So again, the number of groups hasn't changed. I still have 4 groups in total, the x1, x2, and so on. But what's changed this time is the number of darts available, or the number of choices I gotta make. I can only make 6 choices this time. So how many possible solutions are there? There are basically 4 plus 6 minus 1, choose 6 possible solutions. This is going to be 9, choose 6, which, let's put in a calculator. It gives us pretty much 84. Okay, so 84 possible solutions. Okay, so again, another way of thinking about it is to think about it like this. So you had 6 darts and you have 3 groups. So the total is going to be basically 9, because you have 1, 2, 3, 4, 5, 6 darts, and you have to divide the 4 groups with 3 dividers. So in my case, when I wrote it out, I put 3 x's in the first group, then I put nothing in the second group, so there was a divider, and there was another divider with nothing in between, and I put 2 darts in the x3 group, then I put a divider, and then 1 dart in the x4 group. So when I read this, the way I read it is like this. These 3 would represent x1. That would be a total of 3 units. Because there's nothing between these 2 darts, I would know that x2 is basically 0. And then in this case, x3 would be 2, and x4 would be at the end 1. But keep in mind that all these guys have 1 at least. So by adding the extra 1, I recovered the correct amount, which is 4 for the first x, 1 for the second x, 3 for the next one, and 2 for the final one. So again, if you calculate 4 plus 1 plus 3 plus 2, you get the total of 10 that you wanted. Okay. So again, if you think of it as little x's and darts, what can it be seen as? Well, you've got 1, 2, 3, 4, 5, 6, 7, 8, 9 selections, and you're putting basically 3 darts in there, which is the same thing as 84. Or you can think of it as 9, but choosing where the x's go, and you have 6 x's, and that's equivalent also to 84. So try it out, put it in your calculator and find out.